Hey guys, welcome back. It's Geologic History Notes Part 2. We ended talking about the Permian extinction in Part 1, so I'm just going to quickly go over that. Hopefully, you've had a chance to watch the other video on explaining page 8 and 9 on the reference table, and you would understand looking at that page, okay, that the Permian extinction is taking place right over there, okay, right at the end of the Permian time period. Okay. So we're 251 million years ago, largest event we've ever found records of. Okay. I believe I went into all this, but again, I'm going to go real quick through it. 95% of everything that was alive at the time dies. Okay. The animals and life based on land does slightly better than that in the oceans. And we're not 100% sure why it happened. Climate change, volcanoes, change in the magnetic poles, we have no idea. Okay, so largest mass extinction marks the end of the Paleozoic era and the start of the Mesozoic era. So the Mesozoic era is going to be the age of the dinosaurs. Okay, so moving on. After we go through the Mesozoic, at the end of the Mesozoic, 65.5 million years ago, we end the age of the dinosaurs and start the current era, which is the Cenozoic. Okay, at this point, all of the dinosaurs are extinct. Now, this was not shutting off a light. This was something that happened over a time period of about 1,000,000 years. Okay. Okay. Continuing. So, how did this happen? Here's the current theory, and we're pretty comfortable with this because we can actually find evidence of it, but it's not been proven. Nobody was there. So we think that a large meteor comes crashing down into Earth right off the coast of Mexico, in the Gulf of Mexico at the Yucatan Peninsula. All right, so this big, gigantic meteor comes down, hits the Earth, kicks up a huge cloud of dust, okay, and sets off an unfortunate chain reaction. So the dust goes up into the air, which drops temperatures because it starts to block some of the sunlight. Okay, so as the temperatures are dropping, plants start to die. All right, so now the dinosaurs that eat those plants start to die of starvation because those plants are dying. Okay, and then the dinosaurs, the meat eaters that eat the plant eaters, as the plant eaters are dying off, the meat eaters' food source now goes away, so they start to die off too. Okay, so again, it happens over about a period of 1,000,000 years. This also affects things that are much larger than the smaller animals. Okay, and then this leads to the age of the mammals. Okay, so here's an artist representation. Big meteor coming in. Okay, some pterodactyls. All right. So this is the current era, the age of the mammals. All right, began 65.5 million years ago, and it's what we know the most about. Okay, and this makes sense is because it's the uppermost layer of all the rocks, so that should mean we have more evidence and more things to find. Okay, so if we look over here, here's some examples of some of the animals that first came out. Okay, you had ancestors of horses that were very small. Okay, ancestors of some elephants that had a large set of bottom teeth that looked more like a scoop than a tusk. Okay, some camel slash giraffe hybrid looking things. Okay, an ancestor of a wolf. A couple of different things. Okay, so we'll go more into the time periods with our project on the dinosaurs and the lab we're going to be doing this week. Okay, so we're now going to move on to relative age. We only have a couple of slides here, so this is a short lesson today, and then the second lesson for this week is going to be much longer. All right, so putting the time periods aside, if I asked you by looking at this picture to put the three ladies in order from youngest to oldest, you'd be able to do that. Okay? But if I asked you what are their actual ages, you wouldn't be able to tell me that just from the picture. Okay? So relative age is going to be comparing the age of something compared to something else. Okay, we're not working with hard and fast numbers. We're working with just a comparison. All right, so obviously the girl in the middle is the youngest, followed by the one on the left, and then the one on the right is the oldest. Okay, now the opposite of that, as we start to get into these things we're called sequencing, which is what we're going to work on, is putting layers into order and trying to figure out what happened in what sequence. Okay, we have absolute age. All right, so this is going to be the real age of something, and we use radioactive decay or something called half-life to calculate that. We'll get more into what that is and how to calculate that a little bit later in the unit. But basically, we're looking for certain radioactive elements. You've all heard, I assume, well, I shouldn't assume, you should have all heard of carbon dating. That's what this radioactive decay is. That's one form of it. Carbon dating is only useful for things that are relatively young compared to some of the older fossils we'd find. We wouldn't actually use carbon dating because its half-life is too short, so we run out of it too quick. All right, so that's our absolute age. Okay, and actually I'm going to stop there for the first video. All right, and then part 2, we're going to pick up on sequencing and start to work on some problems for that. As I said, we have a lab this week. That's going to take us to the end of May. Then we have 2 weeks in June. And then we're going to end somewhere in the third week. I'm not quite sure if we're going all the way to the 19th or not. They haven't really told us that yet. All right, so hopefully everybody is being good, and I will talk to you guys soon. Thanks.